Hello and welcome to R&D Mathematics. Today we are going to talk about graphing techniques. Actually, there are many techniques that we are going to learn. Today only first two. So the first one, actually all of these are transformations. So transformations. Now first one, vertical shift. So that means, let's say, to graph shift the graph of f of x. If you want to graph fx plus c, so fx after that plus c, what you need to do, c units, actually assuming let's say our c is a positive number, so c units up, and to graph fx minus c units down. Now I need to make a note here. Now this is not f of x plus c. This is a different story. So these two guys, these two are actually fx then plus or minus. So this will go take your graph app, and this is down. Now let's take some examples. Fx equal x squared plus 2. Now the base function x squared, in our last video we learned it looks like this, the parabola. So simply the transformation 2 units up. So 1, 2, the same shape will go 2 units up. And it makes sense, right? Because right in this one is actually x squared, this one is x squared plus 2. See, when your x value is 0, y value is here 0, 0 comma 0. But here when your x value is 0, y value is 2, 0 comma 2. That comes from here. When you plug 0 into this equation, you get 2, right? And that makes sense. Similarly, if you had like gx equal x squared minus 2, what's going to happen is actually here the base function, you always start with base function and 2 units down. So 1, 2, same shape, 2 units down. So this is x squared minus 2. Now that is vertical shift. Now let's talk about horizontal shift. Now I'm going to explain this a little bit more because vertical shift was really easy. Now to graph f of x plus c and f of x minus c, again assuming c is a positive number, shift the graph of f of x. Okay, what do you think? This one, what do you think? Well, your instinct may tell you, see, going to previous page, f of x then plus and minus will take up and down, right? I told you there, this is not f of x plus c. So horizontal transformation actually f of x plus c and f of x minus c. So your instinct may tell you first one is going right, but no, first one is actually going c units left and the second one c units right. So that's a tricky place to remember. Plus goes with right in this case. Now let's see some example and let's verify this for ourselves. Now how about this? F of x equal x minus 2 squared. According to our theory part, okay, you start with x squared. It looks like this. And see here minus 2. So because of that you have to have 2 units right. So your graph will look like this 1, 2. So it will look like this. Now let's actually investigate a little bit more. Now you know what, in order to understand this, how about this? Let me take let me make a simple table so you can understand this. X squared versus x minus 2 squared. Let's plug some numbers and see. When your x value is, let's say, negative 2, negative 1, 0, 1 and 2. So x squared is negative 2, everything squared 4, 1, 0, 1, 4. That's why you get this first shape, this shape. Negative 2 comma 4 somewhere here, negative 1 comma 1 somewhere here, 0 comma 0 somewhere here, 1 comma 1, 2 comma 4. Now let's apply the same thing with x minus 2. So minus 2 squared, that's going to be minus 4 squared, so 16. So this is 16, and here minus 2 minus 1, sorry, minus 1 minus 2 squared, so that is negative 3 squared, 9, and 0 minus 2 squared, so that is going to be 4, and 1 minus 2 squared, that's going to be negative 1 squared and 1, and here 2 minus 2 squared, that's going to be 0 squared, which is 0. Let me take more numbers. So 3 minus 2 squared, which is 1, and 4 minus 2 squared, which is 4. Now let's look at some investigation. Look at these numbers. 4, 1, 0, 1, 4. Here 4, 1, 0, 1, 4. Same values obtained after 2 units. After 2. And in another way, look at this number right here, 2. When our x is 2, y value is 0. So when our x is 2, y value is 0. Earlier, y value was 0 for our 0. So it has shifted 1, 2 units. See, 1, 2 units to the right. So this number 0, 0 coordinate, now 2, 0. It has shifted 2 units. If you check carefully, every coordinate, even this, and every point has shifted 2 units. I think I think you can understand this with this explanation, right? Now, similarly, if you had x plus 2 squared, what's going to happen is, okay, you start with base function x squared. I always suggest you guys to draw it in another picture, because if you draw it in the same picture, it's if you do more than one transformation, sometimes you have to do like 4 or 5 transformations, then it's going to get ugly. So here 2 units left. You can draw the table and check it for yourself, but after this point you don't have to. You just have to remember this transformation and apply them. So it will go 2 units left. How about since this is a little tricky, how about this x plus 2? What do you think will happen? What is the base function? Okay, the base function is this, x square root of x. Now you have plus 2. What will happen? According to our theory part, it will move 2 units left, right? 2 units left, and let's investigate this little bit. So if I take these 2 units left, now we are talking about some negative values of x, right? Remember when we were dealing with square root function, we told you that domain should be positive, but here we are going to negative. Now why does this happen? Because see this function, the radical sign inside the radical sign, the radicand, that part, in order to find the domain of G, this is how we do it. We make it greater than or equal to 0, and we can see when you subtract, x is greater than or equal to -2. Look carefully, guys. It's exactly this. See, the domain, if you project down your graph to x-axis, the domain is greater than or equal to 2, and which clearly makes sense going to the 2-unit left, right? So these are the two transformations that I'm talking about. Actually, you can play with these with all base function, you can find some problem, or you can create your own problem and think about it. Like, for example, x cubed plus 2, what will happen? Oh, f of x equal x cubed plus 2, what will happen? Oh, f of x equal x plus 2 cubed, what will happen? How the graph will change, right? And x plus 2 absolute value, x absolute value x plus 2, x minus 2 absolute value x minus 2. Oh, 1 over x minus 2, the reciprocal function of 1 over x minus 2. So see, these two, this is vertical shift, this is, sorry, this is horizontal shift, this is vertical shift. Like, write down all your base functions, and with each base function, vertical and horizontal, try to figure them out. That's your exercise. Okay, guys, thank you for watching, and let's do next transformation in our next video, and that's going to be reflection about access. Thank you.